today we'll be taking one question. This question is from the modern physics, okay, where we need to calculate the energy in joules. We need to calculate the energy in joules. We need to calculate the energy for what? For the photons. For the photons. And what are those photons? Let me zoom a little. And these photons are given to you of certain wavelengths. So there are two wavelengths given to you, okay, the first and second. What is the first wavelength? The first wavelength is lambda is equal to 3 cross 10 power minus 7 meter, right? And the second wavelength is given to you as lambda equal to 7000 angstrom, right? This is the sign of angstrom. I think you remember. Now, to calculate this, what we need to do, let us see. 3 into 10 to the power minus 7 meter. This is when you write into the form of this meter into angstrom, we can simply just taking the first case, 3 into 10 to power minus 7 can be written as just multiply it with 1000 and divide by 1000. Then you can see 10 power minus 7 and this one 10 power minus 3 will come 10 power minus 10, which is angstrom. So this can be further written as what we did. We just combine 3 and this 1000 together, right? So this will be 3000 angstrom, right? Because this 1000 will be going into the numerator and 10 power minus 7 and 10 power minus 3. Same base exponents will add 10 to power minus 10, which is angstrom. Now, we have both the wavelengths into the angstroms, that is 3000 and 7000. Now we know that the electromagnetic wave, this electromagnetic wave is near which region? Just identify. Near the ultraviolet region, right? And we know that if you remember the energy equation, E is equal to Hc by lambda, right? Where C is the velocity of light, right? And which can also be equated to H mu, where mu is the frequency. So when H and H will be cancelled out, mu is equal to C by lambda, right? So we can say that this mu, this frequency is equal to C by lambda. And here what we have, we will use this relation. Here you can see C is known to us and lambda is given to us. Then accordingly we can find out the frequency, right? The question is that calculate the energy in joules, right? When you calculate the frequency or simply C by lambda, this will be multiplied with the Planck's constant H, then you will get the value of E. So just using direct formula, E is equal to Hc by lambda, which will be giving you the value. Put up the value of H. The value of H is 6.6 into 10 power minus 34. 6.6 multiplied with 10 power minus 34, right, multiplied with the velocity of light. What is the velocity of light? It's 3 into 10 power 8 meter per second, right? So just write it, multiply it with 3 into 10 power 8, it's meter per second, right? And here is joule second. So I'm not writing unit over here, just putting up the values first, right? Hc by lambda. So for, if you consider the first case, for the first case, right, lambda is, you can see, 3000 angstrom, that is 3 into 10 power minus 7 meter. So all in meter, so just put up the value over here, 3 into 10 power minus 7 meter. This is nothing but your lambda, right? Now here you can see 3 and 3 will be cancelled out, and minus 10 will be going to the numerator, and it become 10 power 15, 10 power 15, and this 10 power minus 34 of Planck's constant is already there. So 6.6 into 10 power minus 34 already there, multiplied with 10 power 15. This will give you 6 point, this is in all in joule, right, all in joule, because the unit of Planck's constant is joule per second, joule second. So joule will remain over here. So energy is in joule. So it will be 6.6 into 10 power 15 and minus 34. This will be compensated, added, then 15 will be subtracted from minus 34. So 19 will be left. So 10 power minus 19. 10 power minus 19. So this is the energy of the, this is the energy of the wavelength lambda, I mean to say lambda, where lambda is 3 into 10 power minus 7 meter, this case, where for lambda equal to 3 into 10 power minus 7 meter. And in this way this question is solved, right? So mind the unit, unit is always joule over here, and you want to convert it into electron volts, just divide it with 1.6, okay, you will get the response in your answer in EV, right? Now considering the second question, the second question was for lambda equal to 7000 angstrom, right? So for the 7000 angstrom, so this electromagnetic wave, you can see the frequency is 7000. This is into the deep red region, infrared, right? So deep red region, this one. So now solving the second question now. The second question, we will use the same formula. Energy will be given as H multiplied with C divided by lambda, right? So just simply put up the value, nothing more than that. The value of H is 6.6 into 10 power minus 34. Just let me write the unit over here. Joule second, right? Multiplied with speed of light, that is 3 into 10 power minus 8 meter per second. Let me write unit with a different color, right? Meter by second, mind it. So this second and this second will be cancelled out. Divided by lambda. What is the value of lambda? Lambda is nothing but, you have already seen, 7000 angstrom. So that can be written as 7000 into 10 power minus 10 meter. Here also you can see this meter and this meter will be cancelled out, and we are left with only this joule. So that's why the unit will be in joule, right? And our answer will be, just see, 10 power minus 34 and 10 power minus 8, it will be added, same, minus minus. So 10 power minus 42. So just writing the tenth place only, 10 power minus 42, right? And this minus 10, when going into the numerator, it will be plus 10, right? And here this 3 will be going into the numerator and it becomes 10 power minus 3, right? So this much of joule, and the rest of the terms, that is 6.6 into 3, this 3 divided by this 7, right? Now this will give you minus 42 minus 3 minus 45 plus 10 minus 35, right? Minus 35. Just a simple mistake we did over here, that is 3 into 10 to the power 8 meter per second, not minus 8. So this will be plus, because the speed of light is in plus 8 meter per second, right? So plus 8 minus 34 plus 8 will be minus 28, 26, minus 26. So this will be minus 26, right? Minus 26 minus 3 minus 29 plus 10. So this will be 10 to the power minus 19. This will give you 10 power minus 19 joule, right? And here we have 6.6 into 3 by 7. So this will give you 3 6 18, carry 1, 19.8 by 7. So this will be giving you 19.8 by 7, that will be giving you 7 to 14, 58, 7, 8, 56, 27 to 2.82 approx. So it's around 2.82 into 10 power minus 19. This is the energy. This is the energy for what? for lambda equal to 7000 angstrom. For 7000 angstrom, this will be the energy level, right? And this electromagnetic wave is in the deep red region, and earlier we have seen for 3000, right? This one 3000. 3000 is nothing but this is near the ultraviolet region, right? So students, in this way we have solved both the questions of today, right? If you find it useful, you can just like and be connected. Thank you so much for watching. Take care. Bye bye. Happy learning.